Hi everyone, hope you all are good. We are here for grade 6 math. So we were working on the book Pearson Maths Make Sense grade 6, and we're working on chapter 1, that is patterns and equations. The lessons we're going to cover today are drawing graph of a pattern and understand equality. So let's just start with the first lesson. Okay, here I'm on lesson 6, chapter 1. It is drawing the graph of a pattern. Okay, let's just start with the first example. Record each pattern in a table. Then draw a graph to represent the pattern. Explain how the graph represents the pattern. Okay, let's just start with A, right? Okay, so A, let's start with A. You have to make a table first. So the table, you have to make a table of the values. They are number of figure and number of squares in the figure, right? Number of figure and number of squares. I'm going to make a table of these two values, right? Then we'll make a graph and then you have the ordered pair. Then we'll make the graph of the values, right? So for the first one, figure number 1, you have just one square, right? Figure number 2, you have two square. Figure number 3, you have three square, right? It is in figure number 1, you have one square. Figure number 2, you have two square. Figure number 3, you have three squares. And figure number 4, you have four squares. Okay, the order pair, this is the x value and this is the y value. They make the val pair 1, 1, 2, 2, 3, 3, and 4, 4, right? Let's just make a graph of the values. Basically, you have to plot these ordered pairs on the graph. Let's just plot these values on the graph. So this one is x-axis and this one is y-axis. So 1, 2, 3, and 4. 1, 2, 3. Okay, 1, 1, 2, 2, 3, 3, and you have to make a graph like this, right? If you use proper graph paper, the graph makes a straight line, right? Okay, let's just do for the B part, right? Let's you have to make a table like figure number and dots. Then you have to make the ordered pairs and then you have to plot them on the graph. Okay, figure number, number of dots, and ordered pair, right? Okay, so figure 1, you have 1, 2, 3, 4 squares, dots. Figure 1, 4 dots. Figure 2, 1, 2, 3, 4, 5, 6, 7. We have 7. Figure 3, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Figure 3, you have 10. And figure 4, it is 13. Let me just count once again, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 it is, right? Okay, the ordered pair they make is 1 and 4, 2 and 7, 3 and 10, and 4 and 13. Just make a graph of the values, right? 1, 2, 3, 4. On the y-axis, I'm going to use 1 square as 5, right? Because they have 13 until 13, 5, 10, 15. Okay, 1 and 4. 2 and 7, more than 5 it is. Here is 7 somewhere. Then 3 and 10. Here is 3 and here is 10. Then 4 and 13. Here is 4 and here is 13. Just join the line and join the points and make a line, right? For the C part, you have to do the same thing. You have to count the triangles. 1, 2, 3, 4, 5. Okay, let me just make a table. Then we'll draw a graph. Figure number of triangles, and then ordered pair. One, two, three, four, five triangles, right? That is figure number 1, and you have 5 triangles. Then figure number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. Figure number 2, you have 9 triangles. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. In figure number 3, you have 13 triangles, right? Then figure number 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. In figure number 4, you have 17. 4. Okay, yes, there. Okay, so the ordered pair they make is 1, 5, 2, 9, 3, 13, 4, 17. Just plot the ordered pairs on the graph, right? 1, 2, 3, 4. Okay, I'm going to take one block for 5, right? 5, 10, 15, 20. 1 and 5. 2 and 9. 3 and 13. And 4 and 17. Just join these points and make a straight line, right? You cannot find a work. What do you mean? You can go to the book, grade 6, Maths Makes Sense. We're working on chapter 1, patterns and equations, and the lesson we're working on is drawing a graph of a pattern. You can see the book. Here it is, Pearson Math Makes Sense. That's the book I'm working on. Here is chapter we're working on, patterns and equations, right? And we're working on lesson, I think, lesson 6 it is. Drawing the graph of a pattern, right? Okay, do you find the lesson now? Okay, let's just start with question number 2. Use grid paper, graph each table, describe the relationship shown on the graph. Okay, you are given the table, you just have to plot the values on the graph, right? Let me just make 1, 2, 3. I am going to use an online tool to make a table, right? Because not make the proper graph, but maybe we have a graphing tool here. Let me just check. I think we can, but it's okay. I can plot the points on an online tool, right? Okay. So the points are 1, 3, 2, 6, 3, 9, 4, 12. Okay. 1, 3, 2, 6, 3, 9, 4, 12. Okay. You can see here is the points, right? If you join the points, they make a straight line, right? Also, you have to see the relationship shown on the graph. So you can see the input is increasing by 1, but the output is increasing by 3 points, right? So output is increasing by 3 points every time, right? Okay, let's start with question number 3. For each graph, make an input output table. Okay, you are given with the graph, you just have to locate the values on the graph and you have to make a table of the graph, right? So let's just make a table for A part. Okay, input values and output, that is the graph for. Okay, let's just make for A here. Input values and output. Input is you have to match the values to x-axis, right? And to y-axis 2. And it would be middle of 2 and 4, so it would be 3. When input is 2, output is 3. Input is 4, output is 7. Input is 6, the output is 11. Input is 8, the output is 13. Right? That is the input output table for graph A. Right? You have to do the same thing for B. Input is 2, output is 12. Input is 4, output is 16. Input is 6, output is 20. Input is 8, output is 24. Right? Okay, let's just move on to question number 4. Use grid paper. Draw the graph in the table. Describe the relationship shown on the graph. Write an expression to represent the pattern. Find a number of shapes in the 8 figure. Okay, hold on. Okay. Question number. Draw the table data in the table. Graph the data in the table. Okay, let me make a graph over here. 1126. Okay. 1126. 311, 416, 311, 416, and 521. Okay, here is the points, right? So you have to see the relationship between the values, right? How do you see the relationship between the values? So to move to next point, you have to move one right and five up, right? Because this is the change in y and this is the change in x. So change in x is 1 and change in y is 5, right? You have to move 1 like this and 5 point like this on the graph to move to the next point, right? Describe an expression to represent the pattern. Okay, you have to write the expression. Okay, 1, 2 plus 4 is 6, 3 plus 8, 4 plus 12. Okay, you have to find the expression. It would be start with 1 and add. You have to start with 1 and you have to add 5 for the next term, right? It would be 5n minus 4. You can see when 1, 5 times 1, 5n minus 4. And 5 times 1 is 5. 5 minus 4 is 1. Let's just put 2. 5 times 2 minus 4. 10 minus 4, that would be 6. So that means the expression for that represents the pattern is 5n minus 4. For this pattern, the mathematical expression is 5n minus 4. Okay, find the number of shapes in the eighth figure, right? So just replace the 5n with 8. 5 times 8 is 40 and 40 minus 4 is 36. That means in the eighth shape you have the 36 shapes in eighth figure, right? Okay, could you use the same strategy to find the number of shapes in 18th figure? Yes, just replace n with 18. 18 times 5 is 5 times 8 is 40, 90. 90 minus 4 is 86. That means in the 18th shape you have 86. In the 18th figure you have 86 shapes, right? Okay, let's just look at question number 5. Use grid paper, make a table, represent the figure. Okay, let's just make a table first, right? 1, 4. Figure number and counters. Figure number 1 and 4. 2, 6. 3, 8. 4, 10, and 5 would be 12. How does the graph represent the pattern? You have to move right 1 point and up 1 point, right? Up 2 point, right? Because 4 and 6, you have to move right point and up 2 point. Okay, you have to write down the expression because you have to find the number of counters in 7. Okay, in 6 they are 14, in 7th they are 16. That means in the 7th figure you have 16 figures, right? How many counters? Okay, the equation would be 2n plus 2. It would be 2n plus 2, right? So for the 23rd figure, it would be 2 times 23 plus 2. 46 plus 2 equals 48. That means in the third figure, you have 48 counters, right? Okay, let's just start with the next lesson. Understanding equality. Okay, suppose you were using real balance scales. Equality. Suppose you were using real balance scales. Which scale below would balance? How did you find out? Okay, 72 divided by 9. 9 times what number is 72? This one is 72 divided by 9, right? So 9 times 8 is 72. They have answer 8. Then 13 minus 5. 13 minus 5 is also 8. So both sides have the same answer, right? That means that would be the balance, right? Okay, 12 times 6 is 72 and 12 times 6 is 72. This one also, because both sides have same answer, right? Okay, 19 minus 9 is 10 and 19 plus 9 is 28. Which scale below would balance? This one is not balanced, right? Okay, let's just look at question number 2. Write an expression with two numbers and one operation. Write an expression with two numbers and one operation. Okay, 10 plus 2. Two numbers and one operation, right? Write five different expressions that equal your expression in part A. What strategy will you use to find the expressions? Okay, you have to write five different expressions. They have, like for this one, 10 plus 2 is 12. Now you have to write five different expressions that have the same answer, right? Okay, you can write 8 plus 4, right? 6 plus 6, 5 plus 7, 1 plus 11. How do you write? They all have the same answer, 12. That's how you can write five different expressions, right? Suppose you used real balance scales. Put your counters to represent three of the expressions in the left pan and 3 in the right pan. Okay, so you have now 6, right? 8 plus 4, 6 plus 6, 3 plus 9. Okay, put 3 count 3 of the expressions on the left pan. For example, here is the, so just write down 3 expressions over here and 3 over here, right? 8 plus 4, 5 plus 7, 3 plus 9. But they are balanced because both of them have the same answers, right? So this is the, both sides are balanced, right? Okay, let's just look at question number 3. Rewrite each expression using a commutative property. What is commutative property? Let me just explain first. See, when we add two numbers, their order does not affect the sum. The scales always balance. This is called the commutative property, right? 3 plus 2 and 2 plus 3. So if you just change the order of the numbers, it doesn't matter. The answer would be same. That would be the commutative property. Okay. So the commutative property is if you just change the order of the numbers, the answer is exactly the same, right? Okay, rewrite an expression using a commutative property. So commutative property is 5 plus 8 and 8 plus 5. They have the same answer, right? And for this one, 12 plus 21 and 21 plus 12. This is the commutative property. So for multiplication, it is also same. Either you do 6 times 9 or 9 times 6. They both have same answer, right? So this one 74 plus 134. So this one 7 times 11. So this one 9 times 36, right? Okay, let's just look at question number 4. Are these scales balanced? Okay, 36 plus 27 is 7 plus 6 is 13, 3. 63 minus 50. So 63 minus 50 is 13, right? Let me just use calculator. 36 plus 27, 63 and 63 minus 50 is 13. Yes, 13 and 4 times 3 is 12. Are these scales balanced? No. If your answer is yes, what do you think so? If your answer is no, what could you do to balance the scale? You have to subtract one here, or either you can add one here, right? Because you have to make both the balance, both of side balance. Here you have 13 or here you have 12. Either you subtract one from this side, it would be then 12 and 12, or either you add one this side, it would be then 13 and 13. So you can do either thing to balance the scale, right? Okay, addition and subtraction are question number 5. Addition and subtraction are inverse operations. Addition is commutative. Is subtraction commutative? Use an example to show. Subtraction is not commutative. Addition is commutative, but subtraction is 3 minus 2 and 2 minus 3 is not same. 3 minus 2 is 1, but 2 minus 3 is negative 1. That means just addition is commutative, subtraction is not commutative, right? This is very important point. Addition is commutative, but subtraction is not commutative. Okay, the B part is multiplication is and division are inverse operations, right? Multiplication is commutative. Is division commutative? Okay, let's multiplication is commutative, right? 3 times 2 and 2 times 3 is same, right? But division is not commutative. 3 divided by 2 and 2 divided by 3 is not same, right? Either 8 divided by 2 and 2 divided by 8 is not same. So just multiplication and addition is commutative, subtraction and division is not commutative, right? Okay, we are done with the lesson. So you can please ask questions for the lessons if you have any. I am waiting for the questions from your side. Please ask questions if you have any. No questions? Let me just see the next lesson. Keeping equations balanced. Okay, we'll do the next lesson in the next session. But if you have any questions from the lessons we just did, you can ask questions. I'm waiting for from your side. We'll still have 5 8 minutes. You can ask questions if you have any. We can do if or either from it's your lesson, we can do it on the board. Okay, then that's all for today. See you in the next session. Bye, everyone.